Here's some examples of finding the radius of convergence and the interval of convergence of power series. These are series of the form n equals 0 to infinity cn x minus a to the n. These are centered at x equals a. We're going to find the radius r and the interval of convergence a minus r, a plus r, where you would treat the endpoints separately to see if they're included or not. To find r, we're going to use the limit as n goes to infinity, absolute value of cn over cn plus 1. So some examples. Example 1. Here the a is 5. The power series is centered at x equals 5. The cn is this term here, the n cubed. cn plus 1 we obtained by replacing n with n plus 1. Then to find the r, we take the limit as n goes to infinity of the absolute value of cn over cn plus 1. Because both cn and cn plus 1 are always positive, for n starting at 1, we can drop the absolute value. Here we have a ratio of two polynomials in n of the same degree. They're both degree 3. So we can take the leading coefficient, I'm going to show that in black. So the leading coefficient is 1 times the n cubed, and you'll also have another 1 times the n cubed. Leading coefficients give us in the limit as n goes to infinity 1 over 1, which is 1. Therefore our radius of convergence is 1. The interval of convergence we get by finding a minus r, a plus r. Here the a is 5, the r is 1. So we get 4 and 6 for our interval of convergence. You can treat the endpoints separately using a test for divergence for both, and you would find them both not included. So we exclude the endpoints x equals 4, x equals 6, so these would remain round brackets.